Integration using trigonometric identities. Question number 1. Integration cos square x dx. If you remember, cos 2x equal to 2 cos square x minus 1, and we have cos square x. So what we can do, we can shift 1 to LHS. So 1 plus cos 2x, and we divide it by 2. Then we get cos square x. So in place of cos square x, we can write this thing. So it will become 1 by 2 integration 1 plus cos 2x dx. If you remember, integration cos ax dx gives sine ax divided by a. So we will get 1 by 2. 1 dx will give x, and cos 2x will give sine 2x divided by 2 plus c. Now consider next question. Question number 2. Integration sine cube x dx. This will be equal to sine square x times sine x dx. Now sine square x can be written as 1 minus cos square x times sine x dx. Now we take cos x equal to t minus sine x equal to dt upon dx, or minus sine x dx equal to dt. We have sine x dx, so sine x dx equal to minus dt. So our question becomes integration 1 minus t square times minus dt. So it will become minus 1 dt will give t, and t square will give t cubed by 3 plus c, which is equal to t cubed by 3 minus t plus c. We can put t equal to cos x. So we will get cos x cube, or cos cube x divided by 3 minus cos x plus c. Let's see our question. So next question is sine power 4x dx. So we can write it sine square x into sine square x dx. If you remember, cos 2x in terms of sine is given by 1 minus 2 sine square x, from where we get 2 sine square x equal to 1 minus cos 2x, or sine square x equal to 1 by 2, 1 minus cos 2x. Now sine square x times sine square x, so sine power 4x will be equal to 1 by 4 times 1 minus cos 2x whole square. So this will become 1 by 4 times, we can expand it. So 1 plus cos square 2x minus 2 cos 2x. Further, cos 2x is written as 2 cos square x minus 1. So cos square x will be equal to 1 plus cos 2x divided by 2. So suppose x is replaced by 2x. So cos square 2x will be equal to 1 plus cos 4x divided by 2. So here this term will become 1 plus cos 4x divided by 2. So 1 by 4 plus, sorry, 1 by 4 times 1 plus cos square 2x will become 1 plus cos 4x divided by 2 minus 2 cos 2x. Now we write it further. It becomes integration. We write it separately. So 1 by 4 dx plus, here 1 by 4 is multiplied to 1 by 2. So 1 by 8 dx plus, instead of this, we can open the bracket. So that will be better. So here, first we write 1 by 4 outside. Then we take numbers 1 plus 1 by 2 plus 1 by 2 cos 4x minus, this 1 by 4 is common, minus 2 cos 2x whole dx. Now I'm erasing these things. So first term will become 3 by 2. So 1 by 4 integration 3 by 2 plus 1 by 2 cos 4x minus 2 cos 2x dx. Now we integrate. So 1 by 4 times 3 by 2 x plus 1 by 2 cos 4x, integration will give sine 4x divided by 4. So sine 4x divided by 4 minus 2 sine 2x divided by 2 plus c. We can further write it by multiplying 1 by 4 to each term. Here 2 will cancel out. So this will become 3 by 8 x plus 1 by 32 sine 4x minus 1 by 4 sine 2x plus c. Let's go to next question. Question number 4. Question number 4 says integration cos cube x dx. So it can be written as cos square x times cos x dx 1 minus sine square x times cos x dx. Now we put sine x equal to t. So this will give cos x equal to dt upon dx, or cos x dx equal to dt. So here cos x dx will be replaced by dt, and sine square x will become t square. So integration 1 minus t square times dt. So this will become t minus t cube by 3 plus c, where t equal to sine x. So this will become sine x minus sine cube x divided by 3 plus c. Let's see next question. Question number 5. Question number 5 is integration sine square x divided by 1 plus cos x dx. It can be written as 1 minus cos square x divided by 1 plus cos x dx which would be equal to 1 minus cos x times 1 plus cos x divided by 1 plus cos x dx. So 1 plus cos x will cancel out and we will get integration 1 minus cos x dx. So this will give 1 will become x and cos x will become sin x plus c. Question number 6. Integration sine cube 2x plus 1 dx. Let 2x plus 1 equal to t, 2 equal to dt upon dx, or dx equal to dt upon 2. So our question becomes 1 by 2 integration sine cube t dt. Now this is odd power. Odd power must be converted to odd times even. So 1 by 2 integration sine square t times sine t dt, and we further write it as 1 minus cos square t into sine t dt. Now we put cos t equal to u. If we differentiate it, it will become minus sine t equal to du upon dt, or minus sine t dt equal to du. We have sine t dt. So sine t dt equal to minus d. So our question becomes 1 by 2 minus sine outside integration 1 minus u square d, which will give minus 1 by 2. 1 will become u, and this u square will become u cubed by 3 plus c. Now we put the value of u, so it will become minus 1 by 2 u. U means cos t and t means 2x plus 1. So 2x plus 1 minus u means cos t and t means 2x plus 1. So we can say that cos cube t divided by 3 plus c. Now let's see question number 7. So question number 7 says integration sine cube x times cos cube x dx. So we can convert any one into another. Either sine should be converted into cos, or cos should be converted into sine. So here odd even we apply. So we write it sine square x times sine x times cos cube x dx. Both can't be converted. Any one should be changed. Now 1 minus cos square x times cos cube x times sine x dx. Now let cos x equal to t minus sine x equal to dt upon dx, or minus sine x dx equal to dt. We have sine x dx here. So sine x dx equal to minus dt. So our question becomes minus integration 1 minus t square times t cube dt, which is equal to minus integration t cube minus t power 5 dt, which will become minus t power 4 by 4 minus t power 6 by 6 plus c, or t power 6 by 6 minus t power 4 by 4 plus c. Now we put value of t, so it will become 1 by 6 cos power 6x minus 1 by 4 cos power 4x plus c, which is our answer. Thank you for watching.